Okay, so I just assembled parts of the leg, and there's many parts that we need to change. First, we're going to be using this 30 by 42. Okay, let's go into the leg here and 30 by 42 by 7. One thing I said I was going to do actually is move this entire part up a little bit. So how are we going to do that? It's a good question. We will first, let's see here, get rid of this. Get rid of this. We will first need to get rid of this. We need to do so -3. Create sketch here, and we can do oh, what's the size of this? Look, you forgot. Let me measure it. I think it's 30, right? Yeah, it has to be 30. 100%. Yep, it's 30. Okay, so we can do 30.5. Extrude at -3. Nice. Now this will be sunk into this thing quite a bit. Let me actually check one more thing. This is actually 5, so why not just do 5? Negative, should we do 5? I think that's going to be a good space-saving idea. We could always make this thicker if we need to, and that should, -2? No. -2. -2. The only thing I'm concerned about is the strength, which I doubt will be too big of a problem. So from here to here is 5. This is perfect. Now we can sink the entire, what is this called? Horn into this part, which will be pretty beneficial. And now that we have this, we can now design other stuff, such as this part right here. We will need to extrude this -5. We need to design this entire thing to make it more stronger. Okay, let's bring back everything. Show all bodies. Okay. How do we want to do this, guys? So, okay, let's get rid of this. How do we want to do that? We need to redesign this piece right here. We need to design it in a way. Okay, let's bring this -3. If we did this, how much material do you have? We have, I guess, 2. Extrude this down. Nice. So from here to here is 2. Is that enough? 2 millimeters of material. Probably do at least 3, right? So one more. So this should be 3. Okay, there we go. And now what we need to do is actually, let me think here. This is a center of 20. So let's do a create sketch and do a 20. And let's see here. Extrude at -3. And then now we can go to the sketches and open this up. Extrude 7.5. From here to here should be 7.5. Perfect. And what we can do here is actually get rid of the sketch now. Create a new sketch so that the ball bearing will be able to sit properly. We can go to 24. It goes out to 30 something. It goes out to 32. let's do a 32. Okay, so 32 is there, so this should be fine. Oh no, I did it in the wrong place actually. So finish sketch. And we need to get rid of this sketch here, delete. Create a sketch right here and make it 24, 25. 25 is good. The bigger this piece is without interrupting the ball bearing function will be the best. So we can do a 0.5 here. Oh, wait a minute. This will be... Pause. How will we print this? We could print this upside down? Okay, let's not worry about that right now. I think this shouldn't be too difficult to print. Or we could just print it on its side. Yeah, we should probably print it on its side so that we can increase the strength of this. That would be a pretty smart thing to do. 3 millimeters thick. That might not be thick enough. Let's see here. So let's actually do 4. Let's bring this up 1. Bring this up 1. And we can bring this up 1. Now we'll have 4 millimeters. It should be better. Okay, so we'll have a ball bearing sitting on the outside here. Let's create a sketch and do a ball bearing. So a 20 by 30 something, 32. Let me check real quick. 30, 30, 32 by 7, okay. 32. Extrude 7. A bigger ball bearing will definitely help with everything. Fillet, 0.5. And then we can do appearance. I like to put ball bearings as glass so we can see through it. Glass clear. Just like so. And then we can go to bodies and create a new body. I mean, new component from bodies. Create component from bodies, and then now we can do a joint. This point to this point right here. Flip it, click OK. Nice. So now we have a ball bearing like so. And we can have... Oh, wait a second, actually. Okay, no. This is good the way it is right now. Let's bring back all bodies. Show all bodies. This is 32, so we can actually go here, create sketch, and do a 32. Extrude negative. Let's do extrude and we'll click right here. Should extrude all the way through. Okay, I actually cut all the other stuff and we don't want that. So let's get rid of this, get rid of this, get rid of this. Extrude here. Perfect. Now we can bring back all bodies. Show all bodies. Nice. And now what we want to do is create a... Okay, let me think here. We can either use 1 or perhaps even 4. 4 will be stronger, but look a little wonky. We need to create a cap. And I do want to extrude this more too. So let's go ahead and do that. Extrude. Let me think. Do I want to extrude this more? I think I do. Just do 1 more. Now that we did that, should we do it on the other side? Let me check my model. I think doing it on this side won't hurt anything. Yeah, okay. Let's go like this. Okay, perfect, perfect, nice. So, okay. Now we have a ball bearing. I think what we need to do here is, try to think, how can we make it so that Okay, there's two ways of doing it. One will... is there one that's better than the other? That's a good question, huh? Let's try something here. From here to here is... okay. Here to here is 5. So let's just do 5. Let's do a... yeah, okay, so let's create sketch. From center out to 32. And then do a from center out to halfway. 25 will work. Maybe we want to do 26 here. Or 27. It's probably a better bet here. -5. If we did this, we could put this on, and then we want to keep this entire piece from leaving this. How can we do that? We can do a chamfer of 5. We did a chamfer of 5. And then make a piece. We did a chamfer of 5 here. I think this will be a good idea. And then what we can do here is actually create a sketch here and do... let's see, how do we want to do this? Here and here. We can create... okay, so this is 20. So going 12 should be good. Should we do... okay, should we use M3 or M2 here? I think we should go with... I think going with M3 will be a better idea. Okay, let's actually make this a little bit smaller. $11. This is good because we will need to do 4 here for the M3 inserts. So okay, so for now let's do M3. Not bad at all. Center point here, we'll do 4, click OK. And then what we will have is... actually, let me just start doing it correctly. M3I. M3I for expression will be 3.8 because it will be 4 millimeters. 3.8 will give us good space. So we can do this, click OK. We'll do M3I. And this will be, it'll be 4 long, so we can go down 5. So this looks very good. We'll have heated inserts in here. And then we'll have another piece. Goes from here to here. It's 5. And diameter of this is 37. So we can create a new piece. That's 37. Extrude it out 5. And then, let's see here, what do we do here? Extrude, no, we don't need to extrude here. And then we can just create component from body. And then we can do a joint here and here. And that's perfect. And create a chamfer here of 5. Just like so. And then we can go to, I think it was 11, right? Create sketch. This will be an M3, not an M3i this time. Center point is here. We need to do 4. Nice. This. We can extrude all the way through. Click OK, and then we can bring back all bodies. Show all bodies. Nice. 2. And we can add a fillet or a chamfer here to ensure this part is strong enough. Okay, now that this is done like this will not be going anywhere. This will be quite strong. Let's show bodies. Yep, this looks very, very promising, and I really, really like this design. So we can do this on every single one of them. Another idea is instead of using heated inserts, I could use something different. Pause. Okay, we need to check something because this does not look correct. From here to here is 5. So essentially what we did is we didn't even need to do that. Okay, so let's actually go back and extrude 5. No, we need to extrude this 5. So I'm guessing we need to extrude the other thing 5 too, so I think that'd be fine. Extrude 5. Extrude 5. Okay, I think this is fine. I mean, we don't need to alter that part. That didn't need to be altered. Okay, let's bring back the horn. So I feel like this right here will be a lot stronger. Okay, let me make sure everything makes sense. Okay, so we have this piece right here. We put a ball bearing on top. Actually, what we want to do here is actually... I think everything makes sense. Extrude. We can extrude this out a little bit more. That's good. Okay, so how we would assemble this thing with this piece will come out like this. Put it on the servo. Put on a ball bearing. I'll add 0.1 millimeters of clearance. And then shell bodies. Okay, and then we will put this piece, not that piece, we will put this piece on. It should be pretty easily printable because this is 45 degrees. And then put this piece on afterwards. Okay, yeah. This is not bad. Now let's go ahead and do this to all the other joints. Let's take okay, which one is this? Find in browser. Move. What just happened? Move and move. Okay, why is it not moving? That's a very good question. Move this, perhaps? Okay, there we go. Find and browser. Move all of this out the way. Don't want to keep Seeing none of this. Find in browser. Move. Okay, perfect. All this other stuff, we can deal with that. Okay, now let's keep going. Let's do both of these two then. Okay, so what was the procedure? I did a total length of 4 from here to here. What the heck? Wait. Okay, I'm assuming it's 4.5, so we can do negative 0.5. Okay. Let me check something else actually. Okay. Yeah, that's fine. Let's see here. What are we doing? Create sketch. Do a 20. And we want you to do negative 4. Not sure why. Go to sketches now. Where are sketches? Where are sketches? Extrude 7.5. Let's check how thick this is. 27. Okay, that's fine. Create sketch here. Do a 27. Okay, let's do a project. Point 0.5. And now what else am I doing? I think that's it. We can bring back everything. Let's do it here too then. Extrude negative 0.5. Oh, now that I did this one need to go at negative 0.5. I'm sure that's not too big of a deal. Okay, why is that 4.5? You know what? To keep everything the same, let's just go with this. And then extrude this in a little bit, create a sketch. I don't want to mess too much with everything else. So 20. Extrude to where? Cancel, delete this for now, get rid of it. Here to here is 5. So I'm gonna go C. Negative 5. Do a join. And then go back to sketches. Extrude 7.5. Create sketch. Okay, nice. Now let's bring back everything. Show bodies. Okay. So VV and then not extrude. Not this either. Create a sketch. Okay, nice. So it was 32. Okay, we don't. Okay, where did why is that piece still there? So this, extrude. Can we extrude it so that everything's gone? You can. Okay, nice. Not bad at all. Not bad at all. Okay, now that we have this going on, we can bring back everything. No, what am I doing? Okay, so from here to here is 3.5, which is not ideal at all. We don't want that. 3.5. Here to here is 4.5. Okay. That's because this is 1 less millimeter than this. Okay, so. Okay. If we did that, that's going to change the geometry of this. Essentially from here to here, instead of 32.5, be 31.5. Does it matter? Not that much. Okay, now that they are both equal, we should be able to work with it easier. Okay, at least this and this is now equal. From this old design, let me see here. There's quite a bit of wiggle room. So let's actually bring back all the show bodies. There's quite a lot of wiggle room here and here. So we need to fix that, obviously. Here to here is 4.5. That's not as good as 5, but it will still work perfectly fine. So we need to create a chamfer, chamfer. We maybe make a chamfer of 4. What if we did 5? A chamfer of 5. Would that make it weak? That's a good question. 1, 2. This will prevent it from... Wait, what just happened? Okay, it's fine. Did on this side, we should probably do... Probably shouldn't do it on that side, it would look a little wonky. This will make it a little bit stronger, and we can add a bigger fillet here eventually. Let's see here. Yeah, we can just add a bigger fillet, it'll make it stronger, it's fine. Okay, now we can do diameter 42? That is strange. What is the diameter of this one? 37, okay. That's very strange. Why is this so much bigger? I know why. Okay. Delete. It's because I made this go in. Forgot about that one. Oops. Okay, so I made it go in 27. Create sketch. I need to do that. 32. 32 and 27. I think it was 4.5, I believe. Um, let's just do 4.5. So extrude negative 4.5, join. Now we can do a inspect. Okay, yeah, that's fine, that's fine. This is perfect. 4.5, okay. Now we should be able to do a extrude of, since it's only did 4.5, we should probably do extrude of 4.5. That makes more sense. And then we can see, if that's 37, this would be 36, yep. It's just a little bit annoying, but it's fine. Let's create a sketch here and did we do 11? I believe we did 11. What is that? And we can do M3I 4. Nice. And then we can do a here all the way to the middle of this. And then we can do something like this, and now we can mirror it over. Nice, okay. Extrude, extrude, extrude this one and this one. Not bad. Okay. Okay, actually, I have a very, very great idea. This is actually very smart, and I think this will actually make it a very... Okay, yes, yes, yes. This is exactly what I was thinking about needing to do. So, what we can do here is actually... Let's see here. From here to here is 11.5. Yeah, so let's go to this part. Wait, I did negative. No, no, no. From here to here. Okay, let's just go ahead and do a extrude. Let's select all of this. This will definitely make this hexapod a lot stronger. Which is very good, which is what we want. Nice. This is exactly what I'm looking for. Okay, so this one didn't penetrate through for some reason. Oh, I think it only does one body at a time, so there we go. Nice, nice, nice. So the advantage of doing this is we can add, what's it called? Heated inserts right here, which will make the entire thing a lot stronger. Another thing is actually, we need to find the length of the heated inserts. I'm pretty sure it's a 4x4x4 or M3x4x4. I'm gonna check real quick. I bought, I think, a few thousand of them. So we're gonna be sticking with those. Where is it? Where is it? Okay, where is it? My friend from China sent out that much for me. Okay, where is our text? I can't find it for some reason. Wait, there's a search bar. I'm so stupid. Okay. Yes, right here. M3, 4 by 4.2. Okay, not bad. Okay, okay, okay. What am I doing? What am I doing? What am I doing? Right over here. Okay, so here to here is 11.5. So we can do a M3. Okay, why did it not work? Yeah, this is really weird. I did 4. That is so strange on why it didn't work. Oh, I think I might have clicked the wrong thing. I think I might have clicked the dot. Okay, now it works great. So 11.5. Let me check something. 11.5, we want to leave a space of 5 millimeters. So 6.5. Before I do this, I don't think I'm going to do that. I think I'm going to... actually go like this. Mirror. We can mirror this across here, so now we can select everything at once. And do 6.5, I think. Oh my gosh. There we go. Okay, that's bothering me. I don't know why. That's bothersome. I don't like that. Why is it? You know what? It's fine. I don't think this will affect anything. Okay, here to here should be distance of 5. Perfect. Okay, and let's check here. As long as it's around 5, it'll be fine. 5. Okay, so it's perfect. Now doing this, the screw will dig into the plastic until it hits the heated insert, which will be very, very strong. Let's go ahead and do it here too, before we forget. Okay, so... okay, nice. And then create sketch. M3I. No, just M3. Uh, 4. Extrude. Okay, so this is 0.5 more, so we can do 7. -7. This should leave us with 4.6. That's fine. That's fine. That's fine. It's not a problem at all. Why is this not lined up? Okay, that's a little weird. Oh well. Show all bodies. Hey, why is that not lined up? Did I oh, I extruded that down a little bit. Ooh, I forgot about that. I'm just gonna go like this. I mean, it's fine. There's no problem here. Okay. Anyways, what was I doing? Oh yeah, okay. Now we should be able to 36. So we can create a new sketch here. 36. Extrude. Oh no, I forgot. Is it 4.5? Yeah, it's 4.5. 0.5, and then this fillet should be 4.5 too. Or chamfer. 4.5. Perfect, perfect. This might have a problem of fitting here actually. Oh, we can do it too. And then we can create component from bodies. Join. Actually, before I do that, I'm going to create another one of these. Before I do the create component from bodies, which is this one right here, copy paste. Create component from bodies. Create component from bodies. Nice, okay. Now we can do a joint. Let's put this one here. Nice. Now I can joint. Put this one here. We can actually go ahead and extrude it and do 3. This will make it quite a bit more robust, and we can add the, yeah, this is good. We could even make these caps out of a different color. That'll be pretty cool. We'll just do all black. Okay, so that's really bothering me. This is gonna keep bothering me for a long time if I don't fix it right now. So we're gonna fix it. Okay, extrude 0.1 to add clearance. Nice. Okay, now we can bring back the caps and bring back the sketch also. Here, how do we do this? So let's show all. Okay, not that one. What did I just do? Show all bodies. And show all. Okay. And then we can go to sketches. The last 2 sketches is what we need to do. Okay, how do I... Okay, what is this? Okay, extrude, 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 extrude. Extrude, 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 extrude. Okay, didn't extrude to the side for some reason. Quite weird. It's not a problem. Just go like this. Extrude. Perfect. Nice, nice, nice. Now we can add a chamfer or a fillet. That looks so awesome. Alright, and let's address the issue of clearance. I see that there's a lot of clearance. There's like over a millimeter clearance, which I don't know why, because in the CAD it looks fine. But when I actually printed it out, there's quite a lot of clearance. So in order to address this issue, we will need to figure something out, obviously. An easy thing. Why is this like that? Okay. No wonder, because it's a new body for some reason. That is very, very not what I wanted to see. Okay. What the heck? Alright. Combine. Join. When did that happen? I don't know, honestly. It's on this side too, okay. So let's do a combine, boom, boom. No, no, no. I want to combine this one and this one. There we go, like that. Okay, now everything is fixed. I'm gonna delete this. This will bother me. Alright, fixed. Perfect, perfect. Nice. Not bad. Not bad at all. Okay, so let's deal with the clearance issues now. Let's show all bodies. And we want to deal with this one by itself. So let's do a... Let me think here. How do we deal with clearance issues? I really don't think it will be an issue anymore because of the way this is made. Yeah, it won't be an issue anymore. But this won't be very hard to fix, though. We could just add 1 millimeter on both sides. 1, 1, and that should fix it. Yeah, this is actually, okay, so it's 11 instead of 10. Does that matter? Absolutely not. Let's get rid of this, get rid of this. Actually, that won't be what we need. Okay, let's actually do it. -1, -1, -1, -1. I think we will be going with this design here. This one doesn't fit with the overall design, in my opinion. This might be hard to print. No, it won't be hard to print because everything's 45 degrees. This will probably be easier to print than this. Yeah, I think actually, let me think. How can we print this? We can print this sitting on this. So it won't be, either way, it won't be that bad. Okay, let's bring back everything. Show all bodies, show all bodies. So we've actually fixed quite a lot of issues with this overall design. Nice, okay. Everything looks good. let's just wait for the test leg to print, and then we can go on and add the finishing touches to this build. Very excited for. I just hope it's powerful enough to move something so big, which I really think it won't be that big of a problem, to be honest. My robot is quite strong. This to this is 269. So 270 millimeters. Moment arm. How much can it lift? 25 kg cm. No, 250 cm. Force torque equals force and resistance. So divide distance over. So get force is equal to torque over distance. Torque is 250 divided by the distance, which is 27 centimeters, which is 9.2. Okay, so technically, theoretically, the walking Gant should be able to do 22. So this will be 22 pounds. It'll be 3 legs, so it'll be 66 pounds. Minus 50 for inefficiencies, we'll have 30 pounds. So in theory, this robot should be able to walk with 30 pounds. So this is more than enough, so we're totally fine. We're totally within the acceptable tolerances for everything. Also, let me think here. Let's actually do this and chamfer. Rename this as V2 Hexapod base design leg base design, whatever. And then we will actually do a save and do a save as V2 Hexapod finishing touches, I think. Enter. So the base design is with no chamfers on everything. The finishing touches will have the chamfers. Everything. Refresh. Okay, let's see where our base design is. Where is our base design? Base design leg, finishing touches. So let's go here, which we're already in here. One thing I want to be able to do is... Okay, let's see here. Okay, let's bring back everything. Show all bodies. I think, yep, it's this one right here. Extrude this all the way through. Change appliance. What we're gonna do is extrude this all the way down here so that it lines up evenly. We need to do another extrude, I think on this one right here. Extrude all the way down here so everything lines up. Doing this will make the assembly easier, and it should just be just as strong. There shouldn't be any problems with strength. Need to also check something else. Okay, so yes, we need to add a very big fillet here, something like this. This will make everything very, very strong and sturdy. So this is one thing I wanted to add after printing this part out. Another thing is also I want to add is I want to add a chamfer on the inside of everything. Maybe we should do the, okay, I want to add a chamfer on here so it's easier to put together. we'll do a 0.5 chamfer. Maybe we can just do 1 chamfer. We'll do that in a second. Okay, let me think. What else do we need to do? I really want to add a fan. Adding a fan would be a pretty neat idea in my opinion. I think this is a great sketch. Why don't we try to do it? Okay. I think this is 8.5, right? 8.5. There we go. Okay. Another one here. No, what am I doing? Here to here. Let's make this 30. And so now we can go here. What is this line? This line needs to go from the middle of this line to the middle of this line. And then we can add a 30 by 30. Is that a good idea? Adding a fan. I don't think it is actually, because what we will see with this type of design. Yeah, this is not a good idea because it's going to be by 10 millimeters and we don't have that much clearance. Scrap that idea. Let's not add a fan. Let's just go with passive cooling for now. And if it is an issue in the future, we obviously want to design something to help this. But that's not very big of a deal because we can just change the servo mounting parts. We don't have to change all of the design. So let's go ahead and add in M3Is to everything. And okay, actually let's go to assemble. No, fillets. Okay, we need to add a M3 chamfer. I think we need to do a 2 here. This will be M3 chamfer. So this is so that everything will sit flush. So we need here. Okay, let me think. We need to do M2 chamfer too, actually. So let's go here. Do they even sell? Okay. M2.5 counter. Yeah, this is what I'm afraid of. I don't know if they. This is countersunk, so we're good. They do sell them. What am I doing? Fusion. Okay. Change parameters. M25 countersunk. Here, I think we will do. Do we want to do this actually? I don't want to do this because M2 and M3 is essentially the same. Chamfer M3C. Maybe I don't want to use countersunk here. Do I? Do I not? Maybe I want to use a... For this, I might opt out from using a countersunk and just use a... I think that's what I'm going to do. I'm going to use a washer. So let's actually... create sketch. Okay, how big is the washer? I have absolutely zero idea. Do I have a washer lying around? M3 washer, M3 washer. I think it's 7 millimeters. I'm not sure off the top of my head. Let's look here. M3 washer size. M3 D2 is 7. Okay, yeah, I was right. So we can do a 7.5. -3, -4. How much material do we have? 5. Okay, that's plenty. Okay, this is not bad at all. Also do a fill here of 0.5. Yeah, this looks pretty neat. This is good. This is good. This will work. Okay. We're going to use M3 countersunk here, so we will do a chamfer M3C. So this should sit flush. Let's just go and do all of these first. So create sketch. Okay, actually what we can do is go here. Do I want to do this? Do I want to do this? Let me think. This is unnecessary, I think. We can just do a -4. And add a fillet here and here of 0.5. This is just for elephant foot when it's printing the 0.5. Now we can add a chamfer. Let's go ahead and do this side too. Hopefully I don't mess anything up. Selecting everything is quite annoying sometimes. M3 chamfer. Okay, nice. We should use as much countersunk as possible, I think. So here we'll use countersunk, 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 countersunk. Countersunk here, countersunk here. This might be a problem. I don't know if we can do the countersunk here yet. We might need to fix that first. Countersunk, countersunk, countersunk. Need to do a, let's see here, anywhere else in particular. All of these I will do in a different parts, I guess. So we can just do M3 counter, M3 chamfer. Nice, this looks very, very good. Now let's do delete and then do a M3. Okay, perfect. Alright, so for this, what do I want to do? Let's check something. If we did a why is the okay, that's where I'm looking here. That's what I'm looking at. If we did a 4 and click OK, from here to here is 1.5. Okay, that's fine, that's fine, that's not a problem. So I guess we will do a countersunk here. But will we still be able to add a chamfer of, say, 3? We can. Okay, that's fine then. That's not a problem. Let's get rid of this and let's start from this side so we don't get confused. Get rid of all of this. Okay. So create sketch. We need to do M3 insert. M3 insert. And then we can just go from here. Extrude. Okay, perfect. Now that we have this, we can... Okay, what am I doing? Okay, now that we did this, let's go on here and do this part too. I think just doing circles will probably be faster. So M3I, M3I, go down here, M3I, M3I. Actually very hungry. It's 11:36. I also need to go downstairs to check the 3D printer to make sure it's not doing something weird. Okay, so we have this done now. Now let's go up to this part. Create sketch. M3I. I love threaded inserts. They're such a great creation. Okay, everything looks pretty good. Okay, let's go ahead and... Why is that? Oh, I forgot to do this side. Okay. It's about to say, it's about to say. Why is this not added? Chamfer of M3. Whoa. Why can I not do that? Oh, it's because... Oh my goodness. Because forgot to write C. I just did M3, which is really big. Okay. Wait, is that why? M3C. Okay, yeah, we can do it. Nice. Okay. This looks absolutely awesome. We can also add a chamfer here of 3. Maybe either a chamfer or a fill. I'm not sure yet. To be honest, it's not that big of a difference. You can't tell a difference at all. I feel like this actually looks pretty cool once everything gets screwed in. That would look pretty epic. Okay, so... Two mounting points. This will be... I guess it'll be sturdy enough. It's a little flexy from here to here. If I put my hands here and flex it, it's a little... I can flex it quite a bit. I don't know. But it's not... I mean, to be honest, while it's walking, I really doubt it would break or anything. Also, maybe I can machine this out of aluminum. That'd be pretty cool. Okay, so what am I doing now? Okay, let's bring back all bodies. Show all bodies. And maybe we can add a fillet here. Fillets here. Or chamfer, obviously not a fillet. What am I talking about? Let's do this side and this side. Can I get this? Yes, I can. Can I get this one? Yes, I can. Okay, chamfer M3I. Okay. No, not M3I, M3C. Nice. Okay, another thing, instead of doing this, because this won't be able to print well at all, maybe we can do. Let me try. Wait, actually, I did this before. Let me check. That actually looks pretty good, I think. Yeah, I think I'm gonna go ahead and do that. Most likely. Let me actually do have some M3 screws laying around, and I think I have a screwdriver for M3. Let me go ahead and screw one in and see what it looks like. Okay, change of plans. Don't have M3 screwdriver. Can't do it. So, okay, so I'm either thinking doing countersunk here, or maybe here I can do a create sketch. So we can do a 5.5. And then go straight like this. I think I will probably opt for this option. -5. Something like this. This looks pretty neat too. The rest can be countersunk. Because in some places, I feel like this could be a bolt nut instead of a countersunk would be pretty ideal too. I can decide that later. Let's check everything once over. Here we're good, here we're good, here we're good. Okay, another thing. Here to here is 20. I think what we are going to do here with all of each of these is we're going to do inserts in them too. So let's go ahead and do that. Create sketch. M3I. 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 Either do this or use. Wait. Huh, I'm trying to think. Should I do this? Let's go to this and take a look. Either I can screw this in here, screw that in here, or what I can do is screw this all the way over here. That's 52. But if I did this, okay, do they sell 52? Wait, let me check one more time. 52. So I can probably the best bet is go for 50 millimeter. 50 millimeter M3 screw. M3 by 50, 60 pieces. Yeah, so they do sell them. M3 by 50. I think doing this will be a better idea, to be honest. Why will that be a better idea? Because everything will be more rigid if we join every part together. I think that's what I'm gonna be doing actually, so I can finish sketch, delete this. And actually, to help with the screws being able to go through, there's some details here I can add. I can add a chamfer. Wait, no. Yeah. Okay, let's just do one for now. M. 3 chamfer. This is probably too big, so we can just do a modify, change parameters. Clearance chamfer CC. Clearance chamfer 4 screws to go in. We can probably just do, say what, like a 2? I'll probably just do a 1. Yeah, that should be good. This just makes the overall experience of assembly slightly better. Because sliding this in the body might be a pain to do sometimes. So to do this, we'll be able to line everything up. Okay, nice. You know what? We could put 1 all the way through. This is also 50. Okay, wait a second. This is 50. That other thing is 50. Should I do that or should I? If I did that, it would technically, in theory, be stronger. Because if I do here, there could be a failure point where this splits in the middle, which is quite unlikely. 50, 50, 50, 50. Let's see. It wouldn't have to. Okay, we would have to also cut down this stuff because we won't be able to do 50. And then we have to sand everything, make sure it fits. Do I want to do that? I don't know. We can worry about that later. One thing I think we can work on is airflow right now. Let's do a create sketch here. Where is everything I'm looking for? Okay. And then I can go from here. We can go for a 4 millimeters of space here. Do the same thing on this side. Let's do a project here. 4 millimeters. So 15 by 4. What we can do here is go like this. Extrude this all the way through. Nice. Now we had room, a lot of room for air. Still not compromising any structural integrity. Think. We should also probably do it here too. Okay, how can we do it here though? Should we do it here? Will this compromise anything? I doubt it will compromise anything. Let's see. Let's do a create sketch. $17.5 for extrude. Let's do a -8. Let's do a bow, 2 sides. This to here is 9, so it'll be 17 total. Oh wait, this won't work because we have this. I completely forgot about that. Oh wow, okay. Oh, that won't work either because it'll make this weak. Okay, yeah, we don't want to do that. Yeah, we do not want to do that. What we could do... Actually, no, I think this is good the way it is. Maybe. I think 4 millimeters is good. Because if we go too much, then... Yeah, we don't want to go too much. Actually, change of plans. Maybe we can go 5 and then add a fillet or a chamfer. Do I want to do that? Do I want to do that? I don't know if I want to do that. That would make the printability actually better. So let's do -1. Let's go 5 here. And then we can just go ahead and add fillets of 5 to everything. Make chamfers of 5. I feel like in small spaces like this, chamfers actually do better than fillets. 5? Maybe not 5, maybe we can do 4. Yeah, this looks pretty nice. Okay, yeah, this is awesome. Alright. We should do it here too, but there's not much. 7, so there's not much we can do. We can at least add. I'm trying to think. Is there any pressure being put on this side? Okay, I can just look at my part. Yeah, there's absolutely zero pressure being put there, right? Yeah, I actually don't see any. Okay, that's perfect. All right. So we can possibly. I think it's 7 overall. Yep, that's 7. So let's do. Let me think. If we did 4, no, not this one. Okay, let me just close out of this. Okay, I'm trying to think. Is 4 or 3 better? I think we're gonna do 4, maybe. Also, why is this not fully 15? That's quite weird. I don't understand how good this. It is 15. So I think I just didn't click the end of it. Yeah, that's very strange. I'm gonna go 15. I selected this right, so I don't know why it was not going 15. Let's go 4. And do the same thing on this side. We need to project first though. This is 15, that's good. 4. Oh no. That's the wrong side. -4? Okay, that doesn't work. I'm stupid. Let's just get rid of that. Will I regret this decision? It's a 1 millimeter difference. Will that really do anything? Probably not. Okay, why is this a thing? Are you serious? Why is there a space here? Okay, that's so weird. Why is there... Huh. That's pretty weird. Yeah, that is very strange. How many millimeters is this? Oh wow, okay. Is something not straight? I'm very confused. Why? I'm actually kind of confused on why this happened. Yeah, I'm not sure. Oh wow, I do see a slight angle here. Why is there a slight angle? Okay, that's not very ideal. The angles with this and this. This makes a perfect 90. This makes a perfect 90. This makes a perfect 90. So what is the problem here? I'm not seeing any issue. Wait, the problem would be this one and this one. This and this, perhaps? I really don't know why it's acting up a little bit right now. It's almost as if this and this has an angle, and it absolutely does. Why is that? I have an angle. I don't like angles of very small amounts at all. Okay, let's try to figure this out. Show bodies. It's so minor, we can't even see it. So we're saying that this and this has an angle when it should be, in theory, straight. And the angle is so minor, we can't even see it. Chat, should we ignore it? I'm thinking we should just ignore it, to be honest. I can't be even bothered to deal with this right now. Isolate. Maybe we can still somehow create sketch. We could just do this. I mean, project. This is really not that big of a deal. Unless we're machining this out of titanium, then this would be quite a deal, because for something that expensive, I want everything to be absolutely perfect. Really don't understand when that came into play. When that angle came to be like that. Okay, so let's go here. In the future, if I do get more funds somehow, I really want to create another hexapod. Okay, it depends. If I get a lot of funds, I want to create the entire hexapod with brushless servos. Each one will cost a lot of money. But if I somehow basically get unlimited funds, which probably won't happen, but if I do, I want to create this entire thing out of aluminum and really high powered brushless servos. If I get more funds, I want to create this all over again, but instead of 12 volts, I will use 24 volts. So that's the plan. Let's go with 3. Okay, bring show all bodies. Wait, what? Show all bodies. Show all components. Okay, there we go. Have airflow and why don't we just do this? Yeah, I'm not sure why I didn't do that to begin with. Let's see, from here to here is 10. Okay, so we can do another 5 here, I guess. Do I want to do that or do I want to keep it like this? I think we will go with this and just do a fill of 5. I mean, cut of 5. Okay, so let's go here. Isolate. Create sketch. Project. Okay, why is there, okay. This will be 5. Nice. Okay. Chamfer, 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 chamfer. Chamfer, 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 chamfer. I think I did 4. Nice. Okay. Show components. Nice. This looks very, very good. Most of the finishing touches has been put in place. There is still a few things I could do, which I will not do right now, I think. I think the rest I will do once the rest of the hexapod is printed. Maybe we can go ahead and add some sort of cable management, because that is quite important. Let's see. Looking at the printed version, let's actually measure. Okay, how do I, is there a way I can secure everything? I want the cables to be somehow managed in a way that's good. Or I could just have all of it tied together with a zip tie and just hanging off everywhere, but that would get caught. And in battle, obviously, we don't want that hanging everywhere and getting caught. Okay, so can also do something about that later. Let's go into this part and isolate this, because I think what I want to do is actually add a chamfer here and here. Chamfer of, let's do 1. This will let the servo slide in easier and prevent anything from getting caught. We can do 1.5. We don't want to go overkill. I think 1 should be good. Okay, let's go and show all bodies, show all components. Let's see. Now let's do the same thing with this one here. Isolate. One. Nice. This looks very promising. We could add chambers here, but let's not do that right now. Show all components, and then the last one, this one right here. What am I doing? What do I want to do? Oh, isolate this. Isolate. Should probably name all the components. Does it really matter though? It doesn't really matter, does it? We don't even have that much components right now. And it's not like I'm selling this or anything, so it doesn't have to be pretty. As long as I know where it is, it's okay. Okay, nice. Browser. Show all components. Okay, this is looking very nice. I haven't added the chamfers and stuff to that yet, but we can do that next time, I think. Right now, I'm going to go check out my 3D print of the tibia, which is the part that's gonna probably take the longest. So yeah, I will be back later.